Hello, my name is Dmitri, and welcome back to a course on testing complex intelligent systems and autonomous vehicles. This is lecture number 5, titled Build Software to Test Software. It is the core topic of this course because to test autonomous vehicles, we're using one piece of software, the LGSVL simulator, to test another piece of software, the Apollo simulator. The build software to test software methodology is often used in Exactpro's work to test complex financial systems, such as algo trading, as well as market surveillance and monitoring systems. For example, if we want to test trading algo robots, we can use an intelligent market control system to check their functionality. On the other hand, if we want to test a stock exchange or a market surveillance system, we can use those robots as test tools. Test tools are a broad and important topic. Let's talk about it. But before we dive into it, let me take a little detour. There's a holiday called Earth Day. One of the central themes that it promotes is that the Earth doesn't belong to us, we belong to the Earth. This statement is based on the misunderstanding of animate-inanimate objects' nature. In other words, the objects that possess cognitive abilities and the ones that don't. We often encounter the same mistake when we talk about testing and test automation. People have difficulties drawing the line between something that cannot think and something that makes decisions. There's a movement called the rights of nature. It claims that forests, mountains, and rivers have rights, just like the ones humans have. That's why forests and mountains can be represented in courts. This stems from pagan religions, where idols were imbued with souls. But the truth is that the rights of a river are not protecting the river per se, but the people who represent said river. The same goes for developing and testing. We don't talk about what the tool does, but what the people who represent the tool do. Saying that we belong to the Earth is the same as saying that a person belongs to an apartment or a car. We have rights to a car or an apartment, not vice versa. There's a difference between being capable of cognitive functions and an inanimate object. There's a TV show called The Zoo, where the animals all of a sudden decided to attack and kill humans. And even though it feels like an allegory, there is truth to the story. Throughout history, many species on Earth have attacked humans and threatened their survival. But we did survive and colonized Earth. So how exactly did the humans manage that? We learned to use tools. A tool is an object used to extend the ability of an individual to modify features of the surrounding environment. Although many animals use simple tools, only humans have been observed using tools to make other tools. This ability separates us from the rest. It also ensures our survival and comfortable living conditions. So again, a tool is an object used to extend the ability to modify something that we already have. For example, upgrading a fist to a hammer. We can also add actuators that we do not have. For example, grabbing a pair of scissors to cut something because we lack that ability. Here's another way to extend our abilities. Interacting with appliances via passing signals. That is something we cannot do naturally. We cannot direct the electric current, but the tools we use make it possible. Tools also help us with the abilities that are in short supply. For example, the patience to do something over and over again. Tools assist us when we have to repeat the same thing many times. Tools provide countless automation possibilities and ultimately give humans unlimited power. What is automation? It's a technology or a tool with which a process or procedure is performed with minimal human assistance. Automation or automatic control is the use of various control systems for operating equipment such as steering and stabilization of ships, aircraft, and other vehicles with minimal or reduced human intervention. Automation is implemented in many technological processes, and testing is not an exception. Bill Gates described 2 rules of any technology. The first rule is that automation applied to an efficient operation will magnify the efficiency. The second one is that automation applied to an inefficient operation will magnify the inefficiency. This applies to the test automation process. When we automate, the human element gets replaced. Here we see the web application structure with a human as one of the components. This is how we see the structure, but how does the structure see us? It sees us consisting of 3 parts: the hand, the eye, and the brain. So, in order to remove a human from the process, we have to replace the 3 aforementioned components. The difficulty of replacing each of them varies. The hand is the easiest one, replacing the eye will be harder, and the brain is a controversial topic, and we shall get back to it a little bit later. An autonomous vehicle is similar to this. It has an eye, its sensors, it has a hand, its steering wheel and pedals, and it has something that processes the signals coming from the eye and passes them on to the hand. There's also the PEAS model, which is used in robotics. P stands for performance. This is the system control unit. E stands for environment. This is the system under test. A stands for actuators. These are the switches and the hands. And S stands for sensors. These are the eyes. When you automate testing or develop test tools, it is useful to distract yourself from your current tasks and think about what is the hand, what is the eye, and how do you implement the brain component in your current setting. Is full automation possible? Can you replace the human brain? There is a lively discussion about the subject. The first article I would like to recommend is ISTQB's The Vision on the Future of Software Testing. This article paints a picture of a fully automated testing future. There is also a counter-argument. You can read about it in the article titled The ISTQB is Wrong About the Future of Software Testing, and here is why. The article claims that it's impossible to fully automate the software testing process. The supporters of the Context-Driven School agree with this point of view. And even though the arguments are quite convincing, it's worth mentioning that it wasn't that long ago when we thought that a computer couldn't beat a human in a game of chess, until it defeated the world chess champion. And now it's not even a challenge for AI. It's too easy to automate. The same goes to all tasks that we deem too complex for automation. Every task becomes simple after being solved once. The next article that I would like to recommend is a context-driven approach to automation in testing. This article contains a detailed description of the Context-Driven School point of view on automation. One more article. The title of this one is Test Automation Snake Oil. The first edition of this article came out in 1999, but all the central themes remain unchanged until this day. It goes over the main difficulties of automation as well as the unrealistic promises of its proponents. And the last Context-Driven School's article is co-authored by Michael Bolton and entitled Testing and Checking Refined. In this article, the Context-Driven School draws a strong distinction between the notions of testing and checking. They define testing as the process of evaluating a product by learning about it through experiencing, exploring, and experimenting, which includes questioning, studying, modeling, observation, etc. A test is an instance of testing. And checking is the process of making evaluation by applying algorithmic decision rules to specific observations of a product. A check is the instance of checking. The term automatic testing is used quite often, but the same can be said about automatic programming. When you develop a program, you work with the source code, but at the same time, you use tools such as parsers and compilers. Parsers highlight the parts containing syntax errors, while compilers translate the program text into machine code. So the process involves automatic tools, even though nobody describes it as automatic programming. The Lessons Learned in Software Testing book is another relevant source of information, should you choose to dig deeper into the subject. Lessons 102 through 141 are dedicated to the use of tools in testing and test automation. You can check out Chapter 6 of the ISTQB Foundation Level Syllabus titled Tool Support for Testing. You can also try the Certified Tester Advanced Level Syllabus for details of what the role of a test automation engineer entails. Now, let's answer some questions. Is it possible to test without tools? This course focuses on testing complex intelligent systems. Good testing is impossible without tools. It is similar to asking whether you can dig without tools. In theory, yes. But will it be effective? No. You can use your hands to dig a small hole, but that doesn't even come close to what can be done using excavators and trucks. When we test, we dig around in a big pile of problems trying to excavate information. Good testing requires tools. Good test tool development also requires good testing. If you don't understand what you're testing and why you're testing, you will never develop a good tool. You can't have good testing without automation, and you can't have good automation without testing. When people use tools to test the system, they often underestimate their complexity. We say, build software to test software. Both parts of this expression have the word software in them. People understand the complexity levels of programs we test, but for some reason, they have doubts about the complexity levels of the test tools that control the program under test. Cybernetics tells us that the supervising program must have a greater number of degrees of freedom than the supervised one. You should never underestimate the complexity of test tools. People also underestimate the complexity associated with the requirements for the tool's autonomy. It's easy to create a tool controlled by a human. For example, you want to build a firefighter robot that you control with a remote. Building that is much easier than creating one that can enter a burning building and decide what steps to take without a human's help. The same goes to implementing different levels of autonomy in driverless vehicles. The higher the autonomy level, the higher the complexity level of such a system. When you use test automation tools to partially or fully remove humans from the process, you should think about how it correlates with the levels of complexity. The next question is, do we have to reinvent the wheel? Is there a need to create your own test tools? Our experience suggests that yes, there is value in proprietary tools. The main reason for that is that you have to have control over the tool. If you use open source components, you have the control you need. But if you use something that you cannot change, your testing will be limited. And sooner or later, you won't be able to overcome these limitations while testing a complex system. It's also worth mentioning that developing your own test tool can help you understand the connection between the tool and the system under test. You can use off-the-shelf software in some instances, but in most cases that we encountered, those tools require modifications. So even if you're not trying to reinvent the wheel, you would still have to make adjustments to its spokes and its hub. So you have made a decision to create tools to test software. How many do you need? One? Many? The slogan of one company, one team, one tool seems reasonable enough. But if your only tool is a hammer, then all the problems you encounter will seem like nails. The main task of testing is finding new information. Having a variety of test tools can help you get more information about the system under test. Different points of view always reveal more. On the other hand, the more tools you have, the more difficult it is to support them all. So, what can you do with the test tool diversity? Our model suggests that test tools have two sides, one looking at the human and the other one at the system you're testing. The human side requires convenience and optimization of use. So, the fewer tools we have, the easier it is to master them all. The other side looks at the system, and here we want the opposite. We don't want the system to have it easy. We want the system to experience hardships. The harder it is for the system, the more information we are going to get about what's going on inside it. So, one side calls for minimum diversity and the other one calls for maximum variety. And let's not forget the concept of testability. Testability is the degree to which a system helps us test itself. It is how convenient the connection interfaces are for the test tools to extract information more freely. Testability is a key characteristic that improves efficiency. Testability can be good and it can be bad. It is considered good when the additional interfaces and the tools built into the system help us get information, and it's deemed bad when the additional interfaces and the tools built into the system obscure information. When you're testing the system, take a moment to consider if you have a good testability or a bad one. For example, a system could have an interface which allows you to send only specific messages, limiting us to the ways we can impact the system under test. Fake or bad testability is just as bad as fake testing. Real or good testability is just as good as real testing. Improving real testability is the best way to develop and implement test tools. One more question. Should we test the test tool? On the one hand, when we use a thoroughly tested tool, we get information which is more reliable and stable. Plus, the implementation is much easier. That leads us to an assumption that we should always test the test tool. But on the other hand, we test to get information. The information about the system is very valuable. The information about the test tools, not so much. Whatever we have in the test tool is valuable while we are receiving additional information about the system under test in a convenient and efficient way. The quality of the test tool is less important than its ability to get information. Sometimes even a broken tool helps us find additional problems in the system. It's more interesting to find problems in the software of the autonomous vehicles rather than constantly improving its simulator. A bad simulator can find additional problems. We have to find a delicate balance between what we need and what demands extra effort. Another source of information I would like to recommend is Cam Kainer's article called An Overview of High-Volume Automated Testing. This article reinforces our idea that testing of complex intellectual systems should happen at the confluence of functional and non-functional requirements. When we test an autonomous vehicle, we don't want to test it as a turn-based strategy game. We want to test it at full speed. We can find more software problems this way. High-volume automated testing methods help us create unique test libraries that are quite useful when testing complex intellectual systems. We've been using this methodology for many years now, and to implement it, we create tools like TH2, which went open source at the end of 2020. That's it for today's lecture. Thank you for listening. This topic is very complicated and nuanced, so please prepare your questions for the next Q&A session. Subscribe to this channel and help us get the word out about this course. See you soon!